Okay, so we are finally ready to start our next shape. We've talked about points and lines and planes, and today we're going to talk about angles. And so to start us off, I want you to think about when you're playing pool. You've ever played pool before, and here's your ball, and you want to hit that ball, and you want it to bounce off this side, and it's going to go somewhere. Where is that ball going to go? Is it random at the angle that ball will go, or is it predictable? And so we're going to talk about that here in a little bit, but for now, just be thinking about angles in terms of playing pool. All right, so what exactly is an angle? Well, you guys already know this. An angle is formed by two non-collinear rays with the same point. Okay, so first of all, let's talk about this is the angle symbol. It's just a little miniature angle is what it is. Looks like a slanted L. Miss Benton often draws her angles like a slanted L, but then she does an arc through it. She does that just to that you don't get my L's confused with my angle symbol. But lots of mathematicians draw their angle symbol like that. Okay. So here we have an angle down here at the bottom. You can see we have two rays. We have ray XW going that way and ray XY going this way. So two separate rays, but they both start at point X. So that's technically the definition of an angle. The end point of the rays, you might already know, is called a vertex. Point X is the vertex. And there are three ways to name this angle. You can name it by its vertex. You can call this angle X. You can name it by any, 3 points on the angle. So my angle symbol, you need to always start with the angle symbol. So you could do that. You can call this WXY, or you can call it YXW. Now note, be careful. What letter did I put in the middle of both of these? Well, I hope you're saying to yourself, Miss didn't put the vertex as the middle letter. And that's important. The vertex has to be the middle letter. That's how you know where exactly the angle is. And then lastly, you can also name an angle by a number. So in this case, there's number 2 on the inside of this angle. And so that would be, you could also call it angle 2. All right, so let's practice. In example 1, take a second, pause the video, see if you can name this angle in at least 3 different ways. Okay, so I hope you said it could be angle OG. Remember, O has to be the middle because it's the vertex. It could be angle GOG. It could be angle 1, or you might have also said it could be angle O. So any of those 3 would have been correct. All right. Next thing, there's different parts. An angle divides a plane into different parts, that is. So I bet you could guess the 3 parts are on the angle, the interior of the angle, and the exterior of the angle. I think my number 3 got hole punched. So take a guess what would be a point on the angle, a point inside, what you think might be inside the angle, and a point on the outside of the angle. You can pause the video and write down your guess. Okay, hopefully you said points A and E, or points on the angle, also B. Interior of an angle, all this stuff in here. Could have said point B or point C. And the only exterior point we have, the only one that is outside the angle, would be point F. So how'd you do? Did you get those? let's practice naming some angles in example 2. Name the vertex of each angle. So angle 5, got to go locate angle 5, it's right here. And it looks like angle 5 would be those rays that make up angle 5. So it looks like point M. Angle 3 down here. So the two sides, the two rays that make up that angle are right there. Looks like it would be point P. And last one, angle NMP. The M to the P. So sometimes I'll trace this so I know where exactly N to the M to the P would be point M. And you might have noticed a cheater's trick here. You said M would have to be the vertex since it's the middle letter. You didn't even have to look at the picture. It would automatically be point M. Name the sides of each angle. Now we know we are looking for rays. Sides of an angle are rays. So we're looking for angle 6. Oops. Angle 6 is here. And the sides of that are this ray and this ray. So you have to start with the vertex when you name that ray. Remember, order matters. You have to start with the endpoint. So NM would be one side and NO would be the other. Why don't you try number 6? Pause the video, try it yourself. Okay, again, you said M, trace it in the order that it occurs. M to the O to the P. It looks like O is our vertex, so the two sides, the two rays that make this up would be OM and OP. Again, there's a cheater's trick here. O we know is the vertex, it's the middle letter. So you could just say it has to be OM and OP like that. You can't write your answers like that, but you could identify what the answers are without looking at the picture. All right, write another name for each angle in part C. Angle Q to the P to the R. Well, because of the way it's named right off the bat, I know I could also call it angle RPQ. I could just change the order of the letters as long as P stays in the middle. Let's look and see if there's anything else I could call it. QPR. Oh, we could also call it angle 3. Now, at this point, let's talk about what if I were to call this angle P? What would be wrong with trying to call this angle angle P? Well, it could be angle 1, it could be angle 2, or it could be angle 3, because all three of those have a vertex of angle P. So there's a catch on naming a vertex naming an angle by its vertex. You can name it by its vertex if it's the only angle that has that vertex. But if you have multiple angles that all have the vertex of P, probably not a good idea because then you're not going to know which angle P you're talking about. So let's not write angle P as an option. All right, but then angle 1. Oh, see, we could have called angle 1 angle P because it has P, but we don't want to call it that because that would just be confusing. So let's call it, how about, these are the sides of that thing, so OPM or angle MP. Either one of those would be completely acceptable. Name a pair of angles that share exactly 1 point. Let's look. I can see several situations. It looks like 7 and 8 would not work because they also share this line in common, that ray. 5 and 4 would not work because they share a line or a ray. Looks like maybe 3 and 1 would be one of our best options because they only touch at point P. You could have also said angle 2 and angle QPO. But I'm just going to say angle 1 and all right, name an angle with a vertex P that appears to be acute. You remember Acute means less than 90 degrees. It's a cute little angle, right? And the vertex P, it looks like we got two options. You could say angle 1 or angle 3. You can't say angle 2 because angle 2 is obtuse. One way to measure an angle is in degrees. You didn't know this, but there is another way to measure angles out there. It's called radians. If in this class we're just going to measure everything in degrees. It's like degrees and radians is the difference between like feet and I guess meters. And so to indicate the size degree of a measure of an angle, we write a lowercase n in front of the angle symbol. So, for example, if angle A is 80 degrees, we would write the measure, stands for measure, of angle A equals d degrees. Okay, so just a fun fact here, Ptolemy first referenced a degree when he observed the solar system resulted in a unit of measure, what he called a degree, from dividing the circumference or distance around a circle into 360 parts. Okay, and we'll stop this video here and we'll pick up with the 4 types of angles in the next video.